Hey everybody, this is Pops the Professor for a Science Bite. Today we're going to talk about Punnet squares, and even for good science students, there are times that Punnet squares can trip you up until you really have it down pat. So here we're going to show a genetics cross, and just follow me for a few seconds, and then I'm going to show you a really easy way of doing this. So here we have a very typical type problem that you would have in your book. We have one parent that has the dominant genes big A, big B, and then we have another parent that is heterozygous for those two genes. So as you know, with the first parent, they're only going to have one gene combination that they give, and that's big A, big B. But the other parent is going to have four different combinations that they're going to give: big A, big B, big A, little a, big B, and little a, little b. And at this point, you're probably thinking, Pops, this is exactly the kind of thing that's confusing me, and I really need a better way of doing this. So how about we try it with a slightly different way? How about we try it using coins? Because coins are a really good tool for Mendelian genetics because you have two different sides to them. And in Mendelian genetics, you have a dominant version of that gene and you have a recessive version of that gene. So as long as you have a piggy bank and you have enough coins, you can do any combination of genes. Doesn't matter if it's one gene, two genes, three genes, four genes. It doesn't matter. If you have enough coins, doesn't matter. So here we go. We're going to use heads. I like to use heads as the dominant gene, tails as the recessive. So here we're going to use nickels as our A's. We're going to use dimes as our B's. And so again, head's going to be dominant, tail's going to be recessive. So here we have the genes, the combinations for the first parent. We have big A, big B, big B, represented by heads for both the nickels and the dimes. And we're going to cross that with big A, big B, little b. Follow me so far? Okay, well let's get going with our Punnet square using our coins. So here we have the first combination. You can see the parent that's represented on the left-hand side. That is going to be the big A, big B, big B. There is only one combination of alleles that that parent will have, and that's big A, big B. So we only really need one row of our Punnet square in this situation because of that one parent. For the other parent, they're going to have that four different combinations. So again, it's going to be the same thing where it's big A, big B in the first combination, but then we have big A, little b, represented by heads, tails of our nickel and dime. And then our third combination is going to be little a, big B, represented by tails, heads. And then lastly, we're going to have little a, little b. So here I've put the different gene combinations or allele combinations for those four different possibilities along the top. Now with this in mind, now it's just a matter of adding in what is that complete genome possibility for the subsequent offspring. So here we go. With our first possibility is going to be heads, so big A, big B, big B. The second combination is going to be heads, tails, so it's going to be big A, big B, little b. Third one's going to be heads, tails, heads, so it's going to be big A, big B, big B. And then the last one we're going to have heads, tails, which is going to be big A, big B, little b. To make it even easier, you can take a Sharpie, you can write on your coins, and as long as you have a big enough piggy bank and you have enough coins to do this, you can walk through any Punnet square that you have. It doesn't matter how complicated it is. Just have a different currency, a different denomination for each different gene. So if you have, two or three genes, you certainly want to have two or three different coins. I like to use nickels. I like to use quarters because they're nice and big. It's very easy to see. I hope this helps. Please provide any feedback if you want some additional Punnet squares, even some that are much more complicated. I hope you also check out my video on the X-linked inheritance as well. Thanks. Bye.